In this video, I want to talk about state and state management in React, and specifically how the local storage fits into all of that. The reason for making this video is because I'm realizing that a lot of developers are getting confused both on the state management side in terms of what solution to apply to their specific use case, but also on the local storage side and how to handle that, and even if local storage can be a replacement to state management. And understanding this is really important because state and state management is such a fundamental part of any React application, and you will come across it sooner or later. So join me on this journey to explore state management, the local storage, how they all fit together, and how we can use that to build better React applications. Now, before we continue the rest of the video, I just want to take a very quick moment to talk about the sponsor of today's video, Brilliant. Brilliant is a learning platform that helps you become a better thinker and problem solver. They have thousands of visual, interactive lessons covering topics like math, science, programming, data analysis, and AI. Brilliant has a learning platform that is designed to be uniquely effective. Each lesson that you have on there is filled with hands-on problem solving that actually lets you play with the different concepts that you're learning, which, by the way, is a method that has been proven to be 6 times more effective than watching traditional lecture videos. Their courses are designed to build your understanding from the ground up, and they mix engaging challenges with competitive features and daily reminders to really help you stay consistent. Plus, all of the content on Brilliant is crafted by an award-winning team of teachers, researchers, and professionals from big known places such as Stanford, MIT, Microsoft, Google, and more. And if you're into programming, they have a growing collection of programming courses, which are a fantastic way to build timeless problem-solving skills to really be able to thrive in this ever-evolving world of programming. From learning Python to developing an intuition for computer logic, you're going to get hands-on experience with real programs, and you're going to learn to think like a real programmer. You can start learning completely for free by going to brilliant.org/causes-solutions, scanning the QR code on the screen, or simply clicking the first link in the description. And for all of my viewers, Brilliant is offering 20% off an annual premium subscription, which gives you unlimited daily access to everything that Brilliant has to offer. Thank you once again to Brilliant for sponsoring this video, and now let's get back to talking about state management and local storage in React. Alright, let's begin. Now first, I just want to give credit where credit is due. This video is heavily inspired by this article by Nadia Makarevich. We actually read one of her articles before in a different video, the one about the React compiler. She writes very good articles, and this one is no exception. This one is called, Can we use local storage instead of context, Redux, or Zustand? Basically, local storage versus state management. I'm going to leave a link to this article down in the description if you want to go ahead and read it, or better yet, you can join Import React, which is my free newsletter all about React, where we actually send articles like this every single week to your inbox. Cool. Now, what I've done is I've basically gone ahead and created here a bunch of different examples of different ways that we can use state in a React application. And I want to kind of go over each example from the simplest one to something that is a little bit more complex, and then see at the end how the local storage fits into all of this. And hopefully the goal of this video is to really understand both state management and the local storage and how to use them together. So let's start with the simplest use case of state, and that is going to be local state. So local state is state that essentially isn't accessible by other parts of the application, isn't accessible by other components, hooks, or functions. It's state that is defined in one component, like we have here with the modal component with our isOpen state, and this state is only ever used inside of the body of this component. This is what we call local state. Local state is great, and it has many use cases, right? This is one such use case here. This isOpen boolean here is only really relevant for the actual contents of this modal component, right? We're using it here to determine if we should render this div or not. No other part of the application really cares about whether or not this is open, right? It's something that is only local to this component. One other benefit is because the state is local, we can actually reuse this component here in many different places and have different versions of that state. It's not going to be a shared state, so not all isOpen properties are always going to be in sync, but all of that state is going to be within that one component, and we can share that state, that logic, across multiple places. And this is really the simplest expression of state that you can have have in your React application, and it's the one that as a junior developer, you learn first, right? You learn about the useState hook, how to create a state variable here, and then how to use the setter function to update that value, and that's it. Now, as cool as local state is, sometimes that's not enough. Sometimes you have state that you want multiple components to access. And for that, we're going to see one example here in this lifting state up component. This component over here is rendering two different components. We first have the counter component, and we have this other component here. Now, the counter component has its own local state, this count variable over here. It's using it inside of its body here, and then we're calling the update count function to increment the count on this button click over here. The other component doesn't have any state, but as you can see here in the comment, it would like to access the state from the counter. It would also like to know about the count and maybe show the count or do something to it. Now, because this state here is local, it's only local to this counter component, there is no way for the other component to directly access the state here. What we have to do, if we want both components to have the state, we need to restructure, to reshuffle some things around to make sure that we provide the count to both components. So how do we do that? Well, the way that we do that is in the name of this component, and it's called lifting state up. This is a pattern that you use in React. Whenever you have two components that need the same piece of state, you move that state up, you lift it up to the nearest common ancestor. The common ancestor means the one that is actually rendering both of these components. In our case, it's going to be this lifting state up component. So what we need to do is we need to come here, take the state variable here, we lift it up one layer to this lifting state up component, and now we can actually pass this state to any component that needs it. In our case, both of these components. So we can pass the count in the set count function here. We just have to add these props over here to our counter component, and then we can pass the count to our other component, and we can come here and also add it to its props. And now both of these components, the counter and the other component, have access to whatever they need from that state variable. And now this count here can just render, this other component can just render the count, and now both components are accessing the state. Now, what we did here with lifting this state up is actually an example of state management. State management doesn't just mean to install a library and have some global shared state that is accessible to all applications like some developers might think. State management is simply managing your state. I mean, it's in the name, right? We manage the state by moving it up and then passing it to all the components that need that specific state. Now, we also have to think about the potential downsides and the trade-offs here. Because as good of a solution as this is, and it is valid in some use cases, in some other cases, it's not valid because it does have trade-offs. For example, the biggest trade-off here, and it's really important to understand this about state, is that now, because we put the state in this component here, every single time that this state changes, the component is going to be rendered because that's how React works, which means that everything in its body here is going to re-render, which in this case, it's fine because everything depends on that piece of state. So we actually want a re-render to happen, but we could have some other component here. Let's maybe put an expensive component here that maybe does not use the count. And this one is now going to be forced to re-render even if it's not consuming the count. And this is only because we moved the state variable up one layer. If we had kept our state variable inside of this counter component here, we would not have this problem because again, local state only causes the component that it's in to re-render and doesn't affect the rest of the components. This is actually one way that you can improve the performance of your application. If you have an expensive component that you don't want to re-render, move the state inside one layer deeper so that you isolate that state and only re-render part of the component instead of everything within this component. But we actually did the opposite. We lifted state up, and so now we introduced worse performance in our application, right? So lifting state up is not always the correct solution. Now, let's keep going. Let's look at different ways and other potential solutions that we could use instead. If you come here to this example, this count with provider, here we're doing something a little bit differently. Here we have this count with provider component that is using a React context provider, which we're going to look at in just a moment. And then it's rendering those same components here, the counter and then the other component here. The counter component has the same count and set count state variable, but it's using it from the use count over here. So from the context directly. And then it's doing exactly the same thing. The other component now can also access both of these state variables over here and do whatever it wants. The counter provider component is your typical example of a React context, right? So we define here the types of our context, which has the count and the set count function. We create the context over here, we create our provider, and then we define our variable over here, our state variable, the count and set count using useState. So this is technically local state to this provider over here, but we are providing that as the value property to our context, which is then consumed via this useCount hook. Again, there's nothing fancy here. This just allows us to use this useCount here and then access all of this state variable over here as long as it's within the children of this count provider. So in our case, the counter and the other component will have access to it. Now, again, this is another example of state management. We still haven't installed any external library yet. This is just native with React. Context is a state management solution because we're managing state and we're providing it to different components that need to consume that state. And this, just like all the other solutions that we've seen thus far in the video, has both its pros and its cons. The pros is that we don't have to put any state variable inside of this count with provider component, which is the main wrapper component. All we have to do is just render this count provider here, and everything within it, all of its children, will directly have access to that count without having to put any state variable here. Which means that this count with provider component is never going to be rendered, which is cool because now if we actually want to put some expensive component here, right, and I'm not going to do it, but you can imagine this one is not going to be rendered because this count over here is not re-rendering. So this is another way that we can potentially save the performance by just shifting some things around. Another benefit is that now we no longer have to pass any props to any of our components, which is really cool because in our example of lifting state up, we had to pass all of these props manually. And if we had, for example, in this other component, if we had another component that had to also use the count, we had to pass it one layer deep. And as we know, this is what we call prop drilling. And generally, you want to avoid this in your applications. With the context API, this is not an issue. As long as the component that needs to consume that value is wrapped within a count provider here, no matter how deep the component goes, no matter how many components we have in this other component, we can always run this line of code here and always access the value. We can even skip components. Let's say, for example, this other component doesn't need to use the count directly, but maybe renders another component that needs to use it. This other component doesn't need to have anything to do with the count or with the state. That nested component can just access it directly from the context because that's what it's built for, right? It acts as a provider and everything within it has access to all of its state. And another underrated benefit of using the context API that not a lot of developers think about is the fact that we get to control exactly where we start providing our value. We get to draw the line of where our state is being accessed because maybe this count provider here doesn't need to be accessed by every component in our entire application. Maybe only a subset of those components need to have access to this count provider. We can choose to put this only on a subset of our React component tree and only provide our count to those components and not the rest of the components, which is really great when it comes to organizing your React application. You're able to create semi-global state because it's not truly global, it's not accessible to everything, but it's accessible globally to at least a part of your component tree. And this is a very valuable use case for the count provider, for the context API. Now, of course, the context API is not all positive. There are some negatives, there are some drawbacks that you need to be aware about so you can make the right decision for your specific use case. One of the biggest problems with the context API is that any component that consumes anything from the context, so by using this use count over here, no matter what they consume, they will always re-render if anything in the context changes. So if, for example, here in this other component, we only consumed the count over here, it doesn't matter that we only consume the count. If set count changes, if any other variable that we have in our context changes somewhere else by some other component, this component is also going to be rendered because it's consuming something from the context. We can't specifically select things and only re-render based off of those, at least not with the native implementation of the context API in React, right? And this can sometimes be a problem and even be a deal breaker in some cases, right? So again, it's not always the perfect solution. There are many solutions that you can choose, and the goal for you is to learn all of them, understand all of them, and pick the right one for the job. Now, let's move on to another component here, this count with SOAR. And let's see another example of state management, this time using an actual state management library. So here we have a count with SOAR component. It has a very similar API here. We're accessing the count and the set count, but this time we're getting them from this custom hook here, use count store. the rest of the component is pretty identical. The count store is using Zustand, right? So Zustand is a state management library that allows you to have global state that is truly global. So this over here, this use count store is using the create function from Zustand. We're passing it here the type, which you all know by now, the count and set count. And then we're defining the initial value of our count. And now this is accessible anywhere in our application, and not only in React. Now, the convention is to prefix this with a use so that it becomes a custom hook, because this is a custom hook, so that you can use it directly in a component and not have any errors that you're breaking the rules of React. But this over here can actually be used outside of any React component. You could use this in a utility function in your application. You can use this in some other part of the application. It doesn't have to be something that is React, right? You can just use it anywhere. This is the true meaning of global state. And sometimes this is exactly what you need. You need a solution to be able to have something that is global, to access it both from React, to access it from a different function, because that's what your application needs. And this, again, is a very valid use case and a different use case of state management in React and beyond. Right, so here we can have any number of components. They can be anywhere in our application. They can be deeply nested within our component tree. They can be the root application, right? It doesn't really matter. We can just directly consume this store over here and everything is going to work. Zustand is doing all the work over here because this is a custom hook to actually make your components re-render, even though this is global state that doesn't need React to work. This use count store over here is going to make your component re-render. And as a bonus, you can even come here and you can pass a selector over here to only select a specific part of the state. Let's say, for example, I only wanted to select the count over here. I can come here. I can just remove all of this and get my count over here, and let's remove set count, let's remove this, and now our component is only ever going to re-render if the count changes. It doesn't matter if this set count function changes, it doesn't matter if we have any other piece of state in here, our component is only subscribing to this one piece of state using a selector, and we can now have more granular updates and control over our components and when they re-render. Now, that is not to say that you can't do this with the context over here. You can actually use another library that allows you to provide a selector to the context to get the same behavior. But the point is that state management, right, you can have it global. And now with this, with Zustand, you can use it across the entire application or within any component that you want. Cool. Now with this, let's talk about local storage and let's see how the local storage fits into all of this. Now, before looking at this file over here, I want you to look at all of these components here, all of these different state management solutions, and find me one flaw with them. Find me something that happens no matter what you're doing, whether you're using Zustand or you're using a simple local state here. What is a fundamental flaw with this that the local storage can actually fix or potentially even replace, right? According to the article. The flaw in all of this, which is not really a flaw, it's more of like a missing functionality that you may or may not need based on your specific use case, is that all of these states over here are not persisted. They are going to get cleared as soon as the user refreshes their browser or just closes the tab that they're currently on. Right? Whether we're doing Zustand, whether we have the context provider over here or just local state, every single time that we close the browser, we refresh the page, our state is going to be lost and we're essentially going to be defaulted back to the initial value of the state. Is open is going to be false and count is going to be 0 across all of our components. And that is a flaw, right? Depending on how you view it. That is missing functionality that maybe in your application you want to have. And you cannot do that directly with any of these state management solutions. They just don't support it natively. If you want to have persistence, which is what this is called, you have to go and do something else. You have to store this data somewhere and then rehydrate it whenever the user refreshes or comes back to your application. And that's what local storage is for. Usually we use local storage for this. Local storage, if you don't know, is essentially a place in your browser that you're able to actually store some data about the application. If I come here and open up this browser, open up the DevTools over here, I can come here to the application, I can go here to local storage, and I can see here the domain that we're on, developer way, and I can see all of the key value pairs that this domain has stored. And the cool thing about this local storage is that this is pretty permanent as long as the user keeps the same browser or doesn't manually clear the local storage or something like that. So you can store in here anything that you want, right? It's key value. As long as this is a string over here, which you can just JSON stringify any object or array or whatever, as long as you can put a valid string in here, you can store anything. And some developers are saying that, well, why can't we just use the local storage instead of state? Because the local storage gives us persistence, and we can just always have this state stored here, and then whenever the user refreshes the application or opens up the application again, we can directly have our values in here. Why do we need an external state management solution if we can just use the local storage instead? Well, to be able to answer that, we have to look a little bit at how you actually interact with the local storage in JavaScript, right? And again, this is not specific to React. This is not pure JavaScript. You can use this in React, but you don't have to because it's just pure JavaScript. So here I have a couple of functions that essentially allow me to interact with the local storage. We have get local storage item, which calls the local storage object over here, which is globally available in JavaScript. And we call the get item over here based on the key. And then if we have an item, because we may not have an item, we're going to return a JSON parse version of the item because again, everything has to be a string. And if we want to get an actual object, we have to parse it and stringify it when we set it. The set local storage item is doing something very similar. Now we're setting the item using the key. And here, as I said, we're going to stringify the value to make sure that we're storing a string. And then here we can remove something from the local storage by the key as well. And then we can just clear the local storage altogether and just clear everything that is in there. Important to note, this clear here is only going to clear on your specific domain because local storage is scoped by domain. So you only have access to the local storage of your domain, which kind of makes sense. You don't want to interact with the local storage of other applications because that just wouldn't make sense. Now, if you wanted to use the local storage instead of our state or state management solutions in React, how would that look like? Well, let's come here to our simplest example and let's see. So what we would want to do is let's first take the bare bones, just local storage approach. Let's come here, let's remove our useState and let's do const is open. And here we're going to do get local storage item is open or false. And here I'm just going to import this from our utilities function. Then for our button over here, instead of set is open, we're going to do set local storage item is open. And now we're going to set it to the opposite of our is open. Essentially the same thing that our state was doing, but now exclusively doing through the local storage. Now, what do you think is going to happen here? Do you think that this is going to work? Do you think that this is open here is going to change and then we're going to see or not see the modal based on what we toggle this button here? Well, the answer is that it's not, because what we did here is we just took some normal JavaScript functions and we just put them in our React component. But that's not enough to make it reactive. That's not enough to connect our component to the behavior of this local storage, the behavior of these values over here. What's going to happen is on first render of this component, yes, we are going to check and get that value from the local storage. And maybe we have a value there. Maybe we have is open to true. And so is open is going to be true. But then whenever we click this toggle button here, we're only updating that set local storage in the local storage. We're not updating or we're not telling React anything about this new value over here and that it should re-render. There's nothing that is telling React that, hey, we have a new value here. This is open, is new. So we should re-render to show that new value here. What's going to happen here is you're going to click toggle and you're constantly going to be setting the same value over and over in your local storage because this is not going to change. If this was true initially because we had true here in the local storage, you're constantly going to be setting this to false over and over again because this will always be true until you refresh the page and this whole component gets rerun once again. And then we're going to get false and then you're going to be able to toggle it and then you're going to set it to true. But this is open here is never going to change. The component is never going to re-render and you're never going to see this modal here. And so local storage is not a valid replacement for state management or even state in React applications. It's something that is completely different and it serves a totally different purpose. The local storage is here to persist things, to persist values, to persist data that we want to be persisted across sessions in a user's browser. It is not something that we can use to get reactive state to get our components to re-render over and over again. That's not the right tool for the job. And so that's why we need to have state and state management, because state is specifically built so that our components can listen to it and can react to our state. Using here the initial example is open here. Every single time that we call this set is open, that is telling React, right? This is the behavior of the setter function of state. It's telling React, hey, we have a new value. We need the component to re-render. This is the only way that you can have reactivity in your React applications. Now, that's not to say that you can't use local storage with React, but you just have to approach it a little bit differently. Instead of just directly using this as open here and getting the value from local storage, instead keep the state here, keep the reactivity of React, but then use the local storage to perhaps get the initial value. So we can do here get local storage item, and here we can pass is open. or we can default it to false and we can re-import our function over here. We're still keeping everything that React has, all the reactivity, but now we're just getting the initial value from local storage, or we're defaulting it to false, which was how we had it initially. Now, every single time that we call setIsOpen over here, our component is going to re-render, this is open here is going to change, and we are going to be able to toggle or modal if it's visible or not. However, what this is not going to do is this is not going to set the new value in the local storage. We're only using it to get the initial value from the storage, and then from then on, React is handling everything else, which usually is not what we want. If we're getting the initial value from the local storage, we also should set the initial value or set the value in the local storage as it's being updated. So for that, we have to come here and we have to create here a new function, handle toggle, which will both call the setIsOpen over here and then also set it in our local storage so that we can always keep the local storage in sync with our React application. And then here we can just do handle toggle, and now our component is both going to work on the React side and also on the local storage side. And this is the only way that you can and that you should combine the local storage with state. Again, local storage is not a replacement for state. Local storage is an extension of state, and the extension allows state to be persisted across different sessions in the browser and in the user's journey of using the application. And this would work both with lifting state up, the same concept applies. It would work with a provider over here. We would do the same thing over here, right? We would initialize this from the local storage and then create a setter function to actually update that and also set it in the local storage. And it would also work in this use count store, with the only difference that here specifically, because we're using Zustand, they have a specific solution to just persist the state automatically for you without you having to manage all of this local storage stuff here. Right, so I hope that this makes it clear what state is in React, what state management is, how it works, when you should use different state management solutions, and how you can use the local storage as an extension of that state management that can go beyond the current runtime of JavaScript, which is React, what's running a React application, how you can extend beyond that runtime and persist that same state that you created in React across multiple sessions of the same user. And I hope that now when you're building your applications and you find yourself in a situation where you need to have some sort of state, you need to persist it, you know how to use the local storage, how to combine it with state properly, and you know how to correctly architect your React applications, and even in some cases reduce some potential performance problems. So yeah, this is a phenomenal article. Highly recommend the read. She has a lot of different interesting examples, and she goes even way more in depth than I went in this video, but I think that we covered enough. Again, you'll be able to find this link in the description down below, or if you're joined Import React, which is my free newsletter all about React, you get articles like this delivered to your inbox every single week. So that's it. That's all that I had for this video. If you've enjoyed it, make sure to leave it a big thumbs up. You can also click here to subscribe. You can click here to watch a different video of mine. My name has been Darius Kozan. This is Kozan Solutions. Thank you so much for watching, and I will see you in the next one. Ciao, ciao.